want to have a look at another question on volumetric analysis. This time around, we are finding the concentration of an unknown acid. We are not given the name of the acid. So because H2Y is not a complete name. So how do we find Y? How do we know the concentration of the acid and the percentage by mass of Y in the acid? Okay, the first thing is to write out the given data, which is written here. 20.3 cm cube of a solution containing 5 grams of an acid. This is the volume of that acid. 5 grams of an acid, H2Y per dm cube. When we link 5 grams with per dm cube, it's giving us mass concentration. Mass concentration of the acid is 5 grams per dm cube. Neutralizes 25 cm cube of solution containing 4 grams of sodium hydroxide per dm cube. This 25 cm cube is the volume of sodium hydroxide. And sodium hydroxide is a base. That means volume of base is 25. And the 4 grams of that sodium hydroxide per dm cube, when we link 4 grams and dm cube together per dm cube, is telling us mass concentration of the what? Of the base also. So these are what we have. So how do we now use them to get what we want? The first step is that we will look for where we have a complete information. We notice that we have a complete information on the base, but not on acid. Because we don't know the name of the acid, but we know the name of the base. Therefore, we start from the base. Since we have the mass concentration of the base, and we know the name of the base, sodium hydroxide, that means we can actually find the molar mass of that base. And when we find the molar mass of the base, we can use it in conjunction with the mass concentration of the base to find molar concentration of the base. Though it's not among what we are asked to find, but without having it, we can't find anything here. So the first step is to use this mass concentration of the base and the molar mass of the base, which I'm going to calculate now, to find the molar concentration of the base. That's the first step. You start from where you have complete information. To find the molar mass of sodium hydroxide, we are going to add the relative atomic masses of the elements together. Sodium is 23. Oxygen is 16. Hydrogen is 1. That will give us 40 grams per mole. That's the molar mass of sodium hydroxide. We will now use this to find the molar concentration of the base using the formula. Molar concentration is equal to mass concentration over molar mass. Okay, this is molar concentration of the base we are looking for. So I will use C substitute B to represent that. C represents molar concentration, B for base. That means I will need the mass concentration of the base, which is 4, divided by molar mass of that base, which is 40. That will give us 0.100 mole per dm cube. All right, now we have known the molar concentration of that base. From there, we can now go ahead and find what we are asked to find. The first question asks us to find the molar concentration of the acid, which is Ca. So definitely, I can now use, to find Roman figure 1, I can use Ca Va over Cb Vb is equal to Na over Nb. So this is what I'm looking for, Ca. Volume of acid is 20.3 over concentration. The concentration of base is what I just got, 0.1. And volume of base is 25, equals to NaNb is the mole ratio of acid and base in the equation. 2 mole of base, 1 mole of acid, because there is an invisible one here. That will now be 1 over 2. So let's do the cross multiplication and find molar concentration of acid. So this is the molar concentration of the acid, 0.0616. We always leave concentration in 3 significant figures. So take note of that. That is why it is 0.0616, 3 significant figures. Okay, the second question has us to find the molar mass, the molar mass of the acid. So how do we find the molar mass of the acid now? Since we have known the molar concentration of the acid, we'll go back and use this formula. So this formula is what I'm going to use to get the molar mass of the acid. Molar concentration of acid is what we just got. That's 0.0616. Mass concentration of the acid, remember we are given. And what is that? That is in the given question. Yes, that is 5 grams per dm cube over molar mass we are looking for. By cross multiplication, what will be molar mass? So this is the molar mass of the acid H2Y. Okay, now we can now go ahead and find the third question, and that's the value of Y. How do you find the value of Y? By using this molar mass. Molar mass of H2Y will be equals to the addition of the relative atomic masses of the elements. Since we have 2 atoms of hydrogen, that will be 2 into bracket atomic mass of hydrogen plus Y that we are looking for. And since the molar mass of this acid is 81, the one we just got in Roman figure 2. So this Roman figure 3 we are answering now. So that means 81 will be equals to 2 into bracket hydrogen has atomic mass of what? 1, then plus Y. So definitely 81 equals 2 plus Y. 2 will come to the other side. 81 minus 2 equals to what? Y. So what will now be Y? That will be what? 79. That means the atomic mass of Y is what? 79. Now, finally, to find the percentage by mass of Y. Percentage by mass of Y. That will be mass of Y over mass of H2Y, because Y is coming out of H2Y, times 100 over 1. By substitution, mass of Y is what? 79 divided by 81 times 100. Let's see what that gives. So the percentage by mass of Y in H2Y is 97.5%. So definitely, if you want to know the percentage of hydrogen, that is H2, you just subtract this one from 100. That will give you the percentage by mass of what? Hydrogen. So this will be the end of this question. We have been able to know Y. So since Y is 79, all you need to do is to go to the periodic table and look for the element which has close atomic mass of to 79, and that will be the element Y. Okay? See you in my next video.